Alright, so 7G is about using angle sum and differences identities. So identities are just kind of like the formulas that we get derived and we can use for any type of situation. So we already have seen these sort of identity using the circle equation. We should have identified that, anything plus pi over 2 sine of it will become cos, and then minus of it would be sine, and then you should have identified this, that pi over x, which is a 180 degrees, take x, you should have identified that in one of the questions that we did in chapter 5, I think. And then if you do the same for cos, it ends up being the minus version of it. So you should have studied all that. You should really have this in a cheat sheet because it's quite important. Now, these are some other examples you can use. These are called two angles identities. I'm going to copy and paste it over to each question so we can kind of utilize them really easily. I'm just going to do that really quickly. So we've got 3 examples in total for these, and we should be able to use these angle sums and different identities. So we're going to give them a go. You can definitely have a look at the proofs and all of this on Hazy, but I'm going to skip it. All you need to know is how to utilize it. So the most important thing is for you to kind of copy this green box down first. So if A and B are any 2 angles, okay, then if I have cos of angle A plus or minus B, right, it ends up being cos A, cos B, and then if it's a plus, it becomes a minus. If it's a minus, it becomes a plus. So that's why the sign's flipped of sine A, sine B. If you have a sine of A plus or minus B, it becomes sine A cos B plus or minus cos A sine B. Tan of A plus or minus B becomes, if it's a plus, it becomes a plus. If it's a minus, it becomes a minus, but opposite for the denominator. So just have a look. So easiest way to remember this is when you see cos, sine, it's going to be cos. When you see a mix of both, sine, cos, sine, it's going to be sine. And if you see a fraction, it's going to be tan. Okay, so I just try to remember it like that. So let's give it a go. Expand and simplify sine, okay, 270 degrees plus this alpha sine. Now what you need to understand is you're going to basically be using this identity, right? And you're going to have 2 angles. So this one's angle A, this one's angle B. So that's what you kind of first realize. All I need to do, I'm going to first copy the equation first. So sine A cos B. And because it's a plus that we're using, you're going to be copying the first top one, which is a plus. That's how you visualize it. And then all I'm going to do is now copy this equation, but using the correct A and B. So instead of writing sine A, I'd write sine 270, and then cos alpha, and then I'm going to write cos A, so 270, and then sine beta, no, alpha. Got a bit confused there. Okay, so now I should be able to simplify this without using any calculators because I know how unit circles work, right? 270 angle is a very familiar angle. It's over here. My x-coordinate and y-coordinate is cos theta, sine theta, and my actual values would be x is 0, y is -1. Okay, so I should be able to replace the sine 270 by this answer, -1. -1, so maybe I'll highlight it to kind of note, and then -1 cos theta, alpha, and then cos 270 is 0. So it's 0 times sine alpha, which becomes 0. So all it is my final answer is negative cos alpha, and that's it. I've just simplified it. Alright, so you should be able to do these questions now. Alright, and let's move on. So now we want to simplify this little guy. I'm going to bring this over a little bit so we can use it. So let's have a look what it looks similar to. Well, I can kind of see that there's 2 parts to it. So it's going to be kind of like a reverse version. I notice also that it's cos, sine, so I know that it's going to be cos, sine. So at the moment we've got this, we're going to translate it back to the cos A plus or minus B. So first things first, let's have a look. So I'm going to copy and paste this right underneath it. So cos A cos B minus plus sine A sine B. So we need to figure out which one's which. So obviously A is going to be 3 theta, B is going to be theta. Okay, so let me notice that. A is 3 theta, beta is, so it's not beta, I keep writing beta, but it's actually B is theta. So let's just double check that that works. So my B should have been theta, yeah, good. And then my A should have been sine theta, so it agrees with the second part. Now, which one is it? It's a minus. So when I write my answer, it's going to be, so it's going to be that option. So it's going to be, give me the plus option. So cos, bracket, A, which is 3 theta, plus beta, which is just adding 4 theta. So that's it. I got cos of 4 theta. So now you should be able to do this. Now we're going to do the last one. Without using a calculator, show that sine 75 is something like that. Okay, so we'll give that a go. So first things first, as you can see, it's kind of like a fraction notation. So I know that I'm going to have to eventually probably have to use maybe a 10 or something like that, but we'll give it a go. So first of all, sine 75. Why don't we split it off into a different kind of angles. So sine 75, I could probably write it as sine 40 plus 35. Okay, now if I use that analogy, I should probably be able to use that one, hey. So if I use that analogy, I'm going to have my A is, so that's going to be A, that's going to be B. So I'm sorry, I'm not actually using 10, even though it looks like we're trying to get a fraction. But we'll keep working. A, so sine A, 40, cos 35, plus, because it's a plus first, cos of A, so 40, and then sine of B, which is 35. Now, these angles are not foreign to us. Hopefully, you kind of go, oh, I did something. I didn't split it very well. I really should have. Actually, these angles are foreign, my bad. The ones that I really wanted was 45 and 30. They're probably less foreign, so I'm going to have to just change those numbers. So let me try that again. A. I had the right idea, I just didn't get the numbers right. So my A was 45, 45, 30, 30. There we go. Okay, so these angles are not too foreign to us because it's on the unit circle. So we normally have 30 degrees as our first, and then 45 is our halfway point, etc. And then, what is it, 75? What is our third angle? I actually can't remember. So this is when we go back to our unit circle. Let's have a look. 60 degrees, that's right. But these are the values we're going to be needing. So I'll come back to these. Can't be bothered for copying and pasting it, but we'll come back to these while we do these questions. So what we need is sine 45. Okay, so sine 45 is, without using a calculator, let's figure it out. Okay, let me go back and figure it out. So sine 45 over here is 45 degrees sine square root 2 over 2. So I'm going to go back and copy that down. Square root 2 over 2. Okay, and then I'm going to times cos 30. So let's go back. Cos of 30, so square root 3 over 2. Square root 3 over 2. So that's done. Now I've got cos 45. So cos of 45, square root 2 over 2. And then I've got sine 30. Sine of 30, a half. So now all I have to do is figure out what these turn into. Okay, so I've got square root 2, square root 3 over 4, plus square root 2 over 4. So now, hopefully you can see that it's kind of looking similar. Okay, we've got the same denominator, so you can add them together. And if you realise that, these look the same, these look the same, just the first one doesn't look the same. Well, hopefully you realise that there is a rule in square roots where you can actually times them together. So you are looking exactly the same because you get 6 square root 2 and then 4. And that's it. We got the right answer. So now that's it. We should be able to finish all of these and we're at the end of the topic, I'm pretty sure. Well done, everyone.